We are going to start now the next chapter, chapter 9 of class 10th mathematics. It is some applications of trigonometry. So the first definition we have over here, it is line of sight. So we are saying, suppose we are standing at the point, say O, this is our eye over here, and we are looking at some object at this point P. This is the point O from where we are looking at this object P. Looking at this object means we are looking at it in this direction. So this line, this is called the line of sight. It is when an observer looks from a point O at an object P, then the line OP is called the line of sight. Now, if we draw a straight line at this point O, this is parallel to the horizontal. This is horizontal, we are saying. Then this angle formed over here, this angle we are talking about. So this point is X, then this angle theta, this is called angle of elevation. Angle of elevation of P. So this term you must keep in mind that whenever we are talking about angle of elevation, it means object is lying above us, and this line we are talking about, this is the horizontal line, and the angle formed between the angle of sight and the horizontal line, that is called the angle of elevation. So some examples are given over here, that we can say an aeroplane is flying, this object, maybe some aeroplane is there, or we are talking about the top of a tree we are talking about, or a tower, flag post on the house. All these things, these can be represented at this as this point P. Then we are standing here on the ground and we are looking at this point P from this point O. This line we have drawn over here, this is the horizontal line, and the angle formed over here, that is the angle of elevation. Next is angle of depression. So angle of depression means now we are talking about that we are looking at something which is below us. Now we are at this point, our eye is at this point O. We are looking at some object, say P over here. Then the line of sight is this line. Again we draw a line parallel to horizontal line. This we are saying this is the horizontal line. This line we are saying it is horizontal line. Now this angle that is formed over here, that is between, this is line of sight, this angle theta, this is called angle of depression. So difference between both these is that suppose we are at this point O, we have two objects, one is over here and one is over here. Our line of horizontal line, we are saying this is the horizontal line. For this first object that is lying above us, we are saying this is the line of sight, this is the angle over here. When we are talking about the object at this point, we are saying this is the angle over here. So these are the angle theta we are talking about. This is the horizontal line, these are the line of sight, and this angle, this is the angle of depression, and this is the angle of elevation. Now the first question based upon this, we have a vertical pole stands on a level ground from a point on the ground 25 meter away from the foot of pole. We are saying a pole is there, so this A, B, it represents the pole. It is given that this pole, from this pole we are standing at the point 25 meter away from this pole. We are standing at this point O, which is 25 meter away from this pole. The angle of elevation of top of this pole, it is 60 degree. Angle of elevation of top means this point B we are talking about. This line, this is the line of sight. This OA line, we are saying this is the horizontal line. The angle between the line of sight and the horizontal line, this angle we are saying, this is the angle of elevation. Why angle of elevation? Because the object is lying above the horizontal line. Now we have to find the, question is find the height of the pole. So suppose we are saying the height of the pole, it is h meters. Now we have a right angled triangle OAB. We are talking about this triangle OAB. Now in this triangle, if we write the value of tan theta, theta means we are talking about this angle 60 degree over here, then the value for tan we are saying it is perpendicular over base. Perpendicular for this angle, it is this AB, and the base for this angle it is OA. So what we get is that tan 60 is equal to AB length, we are saying it is height h of the pole, and OA length it is given to be 25. From the table that we have drawn for the T ratios, we know that the value of tan 60 is square root 3. So we get square root 3 is equal to h by 25. So this gives us h is equal to 25 square root 3. The value of square root 3 is given in the problem that we have to take square root 3 is equal to 1.732. So we get h is equal to 25 into 1.732. And on multiplying this, the answer you will get it is 43.3 meters. So we are saying that the height AB, height of this pole is 43.3 meters. Now next we have a kite is flying attached to a thread which is 165 meter long. So suppose at any instant t, the kite is at this point A. Now it is given that, and we are flying it from this point O. Then the length of the string, we are saying this is the string we are talking about OA. Its length is given to be 165 meters. The thread makes an angle of 30 degree with the ground. This is the ground we are talking about. This is the angle of sight we are saying, or this is basically, in this question it is given that this is the thread. So this is just like the angle of elevation. And this is the horizontal line. Now we have to find the height of the kite from the ground, and it is given that there is no slack in the thread. Slack in the thread means that this thread we are saying it is just the straight line. It is given over here. So we have to calculate the height of the kite. It means we have to calculate this length AB, and we are assuming that it is h meters. Now in this triangle OBA or AOB, we are saying we are writing the value of sine 30 degree. That value will be equal to perpendicular over hypotenuse. Why we are writing sine 30? Because we have value of perpendicular, we have value of hypotenuse. So perpendicular we are saying it is h, and hypotenuse we are saying it is 165, and the value of sine 30 we have it is 1 by 2. This value we know from the table. So what we get is that h is equal to 165 by 2, that is equal to 82.5 meters. Next is the length of a string between a kite and a point on the ground is 85 meters. Now in this it is given that this length OA we are talking about, this length is given to be 85 meters. This is the point on the ground we are saying, this is the kite we are saying. If the string makes an angle theta, this angle of elevation over here, this is angle of elevation, it is given theta on the ground, and it is, its value is such that it is tan theta is equal to 15 by 8. Then find the height of the kite from the ground. To calculate this height, we are saying if we write the value sine theta, then the value of sine theta is perpendicular over hypotenuse. Now we don't have the value of sine theta, but we have the value of tan theta. So from this value of tan theta, we are calculating the value of sine theta. And to do this, we have drawn another triangle. We have drawn a triangle whose sides are tan. We are saying this is perpendicular over base. It means we have a triangle. This side it is 8 times k and this side it is 15 times k. So we have to calculate this third side. The value of this third side will be square root of 15 square plus 8 square, and the answer you will get, it is equal to square root of this is k is common, so it is square root of 289k, and that is equal to 17k. So the value of sine theta that we will get, it is equal to 15k over 17k, that is equal to 15 over 17. Now we substitute this value of sine theta 15 by 17 over here. So the final answer that we will get, it is 15 by 17, that is equal to h by 85. So this gives us h is equal to 15 by 17 into 85, and the answer we will get, that is equal to 75 meters. So we are saying the height of this kite is 75 meters. In this question, it is given that a ladder 15 meter long just reaches the top of a vertical wall. So suppose this is the wall AB that is given to us, and the ladder OA, it just reaches the top of the wall. This point A, we are saying this is the top of wall. And now if the ladder makes an angle of 60 degree with the wall, this angle, this is the ladder given to us and this is the wall, and it is given that these two makes an angle of 60 degree. We have to find the height of the wall. This length it is 15 meters, this length it is h meters. So if we look at this triangle over here, we are talking about this triangle AOB. This angle is given to be 60, this is h and this is 15. So if we consider this angle at A as 60, it means for this angle, this is the base, this is the hypotenuse, and this is the perpendicular we have. So if we write the value of cos 60 degree, the answer we will get, it is cos 60. We are talking about this angle. So it is base over hypotenuse. Now the base value we have, it is h, and the hypotenuse is given to be 15, and the value of cos 60 we have, it is 1 by 2. So the value of h that we will get, it is 15 by 2, that is equal to 7.5 meters. So we are saying that the height of this wall is 7.5 meters. Now the next question we have, if a tower 30 meter high, we are talking about this is the tower given to us, and it is given that this tower is 30 meter high, and it casts a shadow 10 root 3 meter long. This is the shadow that this tower is casting. Shadow means the position of the sun. The sun is at this point, so the rays are coming in this direction. So this point over here, the shadow will be casted like this. So we are saying this is the tower and this is the shadow. The lengths of the tower and the shadow, they are given, and we have to find the angle of elevation of sun. So angle of elevation of sun means that if we are standing at the point O, we have to find this angle theta. So if we write the value of tan theta, we have the formula for tan theta, that will be AB over AC, that is 30 over 10 root 3. This gets cancelled, we are left with 3. So it is 3 by root 3. Now if we rationalize this term, we get it is square root 3 by square root 3. These two values, when these are multiplied, we get 3 and these two gets cancelled, and the final answer we get it is square root 3. And we know that what we are getting is that tan theta is equal to square root 3, and we know that the value of theta is 60 degree when tan theta is root 3. It means the value of theta, that is the angle of elevation of sun, we have it is 60 degrees. Next is, if a 1.5 meter tall girl is at a distance of 3 meter from a lamppost and casts a shadow of length 4.5 meter. So what we are saying is, suppose a girl is standing over here. We are representing it with a straight line, and we are saying that a pole is also there. This is the pole that we are talking about. Suppose the position of the sun, it is over here. At this point we have sun over here. So we are saying the shadow that will be casted over here, it will be in this form. The rays of the sun, they will be falling at the same angle on both the girl and the pole. So we are saying the shadow of the girl that will be formed. We are saying this is the girl, this is the pole. So the shadow of the girl that is being formed, it is of this length, we are saying. Now the height of the girl, it is given to be 1.5 meter, and the height of the pole, it is given. It is to be calculated. So suppose we are saying the height of the pole that we have, it is h meter. The distance of the girl from the pole, it is given 3.5 meter, and it is given that the girl, she casts a shadow of 4.5 meter. So this is the situation given to us. Now suppose we are saying the angle of elevation of sun, it is theta. If we talk about this whole length over here, so that will be 4.5 plus 3 meter, that is equal to 7.5 meter. This value we are saying it is 3 meter over here. So what we are talking about is that we have two triangles now. One is the triangle ECD, and second triangle we are talking about it is EAB. This angle we have considered, this angle is theta. So if we write the value of angle, this tan theta, now from the triangle, we are talking about this triangle, it is ECD. The value we have, it is DC over EC. And if we are considering this larger triangle over here, the value we get, it is AB over AE. Now the value of DC we have, it is 1.5. This is the value of DC, over the value of EC we have, it is 4.5. That is equal to value of AB we have, it is H, and value of AE we have, it is 7.5. So on solving this, we will get H is equal to 1.5 upon 4.5 into 7.5. So these two gets cancelled, we are left with 3, and the answer we get, it is equal to 2.5 meter. So we are saying that the height of the pole, it is 2.5 meters. Now another way to solve this is using the similar triangles. What we are saying, if triangle AEB, we are talking about these two triangles. In both these triangles, this is the common angle. This angle at C and angle at A, these are of 90 degree measure. So both these triangles, they are similar, and we will obtain this same result from the similarity also. We are saying from this result we are obtaining from the similarity, and this result we are obtaining by using the P ratios. So both these are the same results, we will obtain the same answer. So it is up to you that how you want to solve this problem. Now in this question it is given that the shadow of a tower when the angle of elevation of sun is 45 degree is found to be 10 meter longer than the angle of elevation is 60 degree. Suppose we are talking about a tower. The tower is there and the position of the sun, it is given to us that at some instant of time the position of sun is at this point and after some time the position of sun is at this point. When the sun is at this point, it is casting the shadow over here. When sun is at this point, it is casting a shadow over here. When we join these two points, we are saying suppose this angle it is 60 degree angle and this angle it is 45 degree angle. We have to calculate the height of this tower, and what is given to us that if this length is x, that is the angle, the height of the tower we are talking, length of the shadow we are saying it is 10 meter longer when the angle of elevation is 45 degree. So we are saying how much longer it is 10 meter longer. It means this total height length is 10 plus x meters. We are talking about this length, it is 10 plus x meters. So we have two triangles over here. We are talking about these points. We have mentioned this is D, C, A and B. So first we are talking about this triangle ABC. Now in this triangle ABC we have tan 60 degree, that is equal to h by x. And in this second triangle, we are talking about this triangle ABD, we are saying the value we have is tan 45 degree, that is equal to h over x plus 10. Value of tan 60 we are saying that is equal to square root 3, and value of tan 45 we are saying it is 1. So we have two equations. One is h is equal to square root 3x and second is h is equal to x plus 10. Now we have to solve these two equations. So if we equate both these values, we get root 3x is equal to x plus 10. So this gives us x is equal to, when we shift this term on this side, we get it is root 3 minus 1x, that is equal into, we are talking about it is 10 over there, so it is 10 over root 3 minus 1. The value we are obtaining over here, I am writing it again, it is 10 over square root 3 minus 1. When we rationalize this term, we are writing root 3 plus 1 over square root 3 plus 1. So answer we are getting it is 10 square root 3 plus 1 over 3 minus 1. This becomes 2. These two gets cancelled and we are left with 5. So the answer we are getting it is 5 into the value of square root 3 is given to be 1.732. So it is 2.732, that is equal to 13.66 meter. Now we want to calculate the value of h. So the value of h that we will get, it is 13.66 plus 10. We are substituting this value in the second equation and we will get it is 23.66 meter. So this is the value of h, that is the height of this tower. Now next we have the term sun's altitude. Sun's altitude is just the value we are saying angle of elevation of sun, that is the term used sun altitude. This is for this whole term we are saying the angle of elevation of sun from the earth, we can just say it is called the sun's altitude. So the next question we have is that a tower is 50 meter high. We are saying the height of that tower, it is given 50 meters and it casts a shadow. The shadow of this tower, it is x meter shorter when the sun's altitude is 45 degree. So suppose we are saying this is the shadow casted when the sun's altitude is 45 degree, and second we are talking about this is the shadow casted when the sun's altitude is 30 degree. Now it is given that this shadow is x meter shorter than this shadow. Suppose the value of this is y. Now we are talking about two triangles. One is the triangle QPA and one is QPB. So when we are talking about the triangle QPA, what we have is that tan 45 that is equal to 50 over y, that is equal to 1. So this gives us y is equal to 50. We obtain that the value of y is equal to 50 meters. In the second case, we are talking about this whole triangle over here. We are talking about this triangle. So in this we are saying tan 30 degree that is equal to 50 over x plus y is 50. The value of tan 30, it is 1 by root 3. So what we get on solving this is that x plus 50 is equal to root 3 times 50. So the value of x that we will get, it is 50 root 3 minus 50, that is equal to 50 into root 3 minus 1. The value of square root 3, it is given to be 1.732. So the answer we get, it is 50 into 0.732, that is equal to 36.6 meters. So this is the value of x that we obtain. Now next we have the shadow of a tower standing on a level ground is found to be 30 meter longer when the sun's altitude is 30 degree than when it is 60 degree. So we are talking about the situation that from this point D, the sun's altitude is 30 degree. From this point C, the sun's altitude is 60 degree. Suppose we are saying the height of the tower, it is h meter, and what is given to us is that the shadow is 30 meter longer. We are saying this length we are talking about, this is 30 meter, and suppose the shadow, the length of this shadow, it is x meter. So we are talking about two triangles. One is this triangle ABC. In this triangle we are saying it is tan 60 is equal to root 3 is equal to h by x. Second, we are talking about this larger triangle over here. So it is tan 30 that is equal to 1 by root 3, and that is equal to h over x plus 30. If we divide these two equations, we will get root 3 into root 3, that is equal to h by x into x plus 30 by h. These two h gets cancelled. We get 3x is equal to x plus 30. So the value of x we get, it is equal to 15 meter. Next, when we are talking about the value of h, we substitute this value in first equation and we will get it is root 3 times x, that is equal to 15 root 3, that is 15 into 1.732, that is equal to 25.98 meters. Next we have is from a point O on the ground, the angle of elevation of the top of a tower is 30 degree and that of the top of a flagstaff on the top of that tower is 60 degree. So suppose we are saying this AB is the tower and this BC that lies on it, this is the flagstaff. This is the flagstaff. Now the height of this flagstaff, it is given to be 5 meters. Suppose the height of the tower, it is given to be h meter, and the distance of this point O from where we are measuring these angles, it is x meters. This distance we are saying it is x meters. Now what is given to us? That angle of elevation, it means we are talking about this angle over here. This angle is 30 degrees. This is for the tower. At the angle of elevation for this flagstaff, it is 60 degree. So what we are saying is that this is the tower. We are standing at this point. If we are looking at the height of this end point of, we are talking about this AB is the tower. When we are looking at this point, this angle is given to be 30 degree. And then we are talking about the angle of the flagstaff. So we are talking about two triangles over here. First is this triangle AOB. Now in this triangle AOB, we have tan 30 that is equal to 1 by root 3, that is equal to h by x. In the second triangle, this larger triangle we are talking about, we have tan 60, that is equal to root 3. The total height over here, it is h plus 5 divided by x. Again, if we divide these two equations, we will get 1 by root 3 into 1 by root 3, that is equal to h by x into x by h plus 5. These two x gets cancelled. The answer we are left with is h plus 5, that is equal to 3h. So we get 2h is equal to 5. So this gives us h is equal to 2.5 meters. You get that the height of the tower we have to calculate, it is 2.5 meters. Next is two pillars of equal height stand on either side of a road which is 100 meter wide. So we are talking about a road, AC is there. This road is 100 meter wide and two towers of equal height, they are on the both side of this road. We are saying this is AB and this is CD. These are the two towers on both sides of this road and their height, they are same. We are saying their height is h meters. Next, we have a point O on this road from which the angle of elevation of one tower is 30 degree and the angle of elevation of another tower is 60 degrees. So we have to find the position of this point O and we have to find the height of the towers. So what we have considered is, suppose the position of this point O corresponding to this A, it is x meters, it is x meter away from this tower A, then this length will be 100 minus x meters. Again, when we are talking about this triangle OAB, we have tan 60, that is equal to square root 3, that is equal to h by x. When we are talking about the triangle OCD, we have tan 30, that is equal to 1 by root 3, that is equal to h over 100 minus x. If we divide these two equations, we will get root 3 into root 3, that is equal to h by x into x. It is 100 minus x over h. These two h gets cancelled and what we get is 3x is equal to 100 minus x. So this gives us 4x is equal to 100. This gives us x is equal to 25 meters. X is 25 meter means this point we are saying O, this is 25 meter away from one of the towers. Next we have to calculate the value of h. So we are substituting this value in the first equation and we will get h is equal to 25 root 3, that is 25 into 1.732. The answer we get, it is 43.3 meters. So this is the height of these two towers which are equal in height. We are saying their height is 43.3 meters. Next we have is the angle of elevation of an aeroplane. So we are saying an aeroplane is there and its angle of elevation, it is given to be 60 degree. Suppose the aeroplane is at the point A when its elevation is 60 degree. We are standing at this point. Aeroplane is at this point. We are saying angle of elevation means this is the horizontal line, this is the line of sight. The angle between these two, it is 60 degree. After flight of 15 seconds, the angle of elevation changes to 30 degree. Now we have two conditions. Either the aeroplane is moving in this direction or it can move in this direction. We are saying if the aeroplane moves in this direction, suppose after 15 seconds it reaches this point, then the angle of elevation will increase. But what is given to us is that after 15 seconds the angle of elevation changes to 30 degree. It means after 15 seconds the aeroplane is at this point and that is why the angle of elevation changes to 30 degree. So we are saying originally the aeroplane was at point A. Now after 15 seconds the aeroplane has reached this point B and angle of elevation corresponding to it is 30 degrees. The time taken between these two, it is 15 seconds. If the aeroplane is flying at a constant height of this height, this is given to be 1500 root 3 meter. We have to find the speed of the aeroplane in kilometer per hour. So suppose we are saying that the speed of the aeroplane is x kilometers per hour. It is x kilometer per hour. If the speed is x kilometer per hour, then how much distance it will travel in 15 seconds? We have to calculate this. So the distance traveled by this aeroplane in 15 seconds, that will be x into 15 by 60 into 60, and we are converting this kilometer to meters because this value is given in terms of meters. So we are saying this is the total distance traveled by the aeroplane in 15 seconds. Now we are talking about the condition over here, the figure, that final figure that we get. This is the line A, B we are talking about. Then we are saying we are joining these 2 points, and we have the condition like this, and we have joined this point. Now what we have to calculate is, we have to calculate this distance A, B. So if we are talking about this triangle, we are talking about, this is OCD. I am talking about the triangle OAC. In this triangle, we have this angle is 60 degree. So it means tan 60, that is equal to the height. So this height, it is h, this distance, it is say y. So we are saying tan 60 is equal to h upon y, and this is equal to root 3. When we are talking about this second triangle, that is OBD, we have tan 30 is equal to the height, it is h, and the distance traveled, this suppose we are saying it is z. So we get it is y plus z. Now the value of h that is given to us, we are talking about this h height, it is 15 root 3. So what we get from this equation is that 1500 root 3 upon y is equal to root 3. These two gets cancelled, and we get y is equal to 1500 meters. If we substitute this value in this equation, we will get tan 30, it is 1 by root 3, that is equal to h is 1500 root 3 upon the value of y we have, it is 1500 plus z we want to calculate. So this gives us 1500 plus z is equal to 1500 into 3. So we get the value of z is 3000 meters. Now from the figure it is clear that the value of z we are talking about, it is this, and we have seen over here that the distance traveled by this aeroplane in 15 seconds is this value. It means both these values should be equal. So we are saying x into 15 into 1000 over 60 into 60, this is equal to the distance traveled by the aeroplane. So these gets cancelled. We are left with this, that x is equal to 720. This is the speed of the aeroplane, it is 720 km per hour. Next is the angle of elevation and depression of top and bottom of a tower from the point of a building 60 meter high. So we are talking about, we have a building that is 60 meter high over here. We are standing at this point D, and we are looking at the top and bottom of another tower, and their angle of elevation means, if we are standing at this point D, the angle of elevation means we are looking at this point B, this is the line of sight, and this 30 is the angle of elevation. And angle of depression means we are talking about, this is angle of depression, because From this point D we are looking upward and we are looking downward. When we are looking downward we get the angle of depression. When we are looking upward we get the angle of elevation. The height of this building is given to be 60 meters. Then we have to find the difference between the heights of the building and the tower and also the distance between them. So we consider that the height over here, the difference of height, it is h meters. We have to calculate the difference between the heights of the building. So we are saying let that difference be h meters. Now we are talking about two triangles. First we are talking about the triangle DEB. In this triangle we are saying tan 30 that is equal to 1 by square root 3 that is equal to h over DE. Next we are talking about this triangle AED. In this triangle we are saying this angle is 60 degree over here. This angle is 60 degree. So corresponding to this angle we are saying this is the base. For this angle this is the base and this is the perpendicular. So the value of tan 60 degree that is equal to root 3 that is equal to perpendicular. Perpendicular over here it is AE over base it is DE. Now the value of this perpendicular that is equal to 60. So if we divide both these equations we get 1 by root 3 into 1 by root 3 that is equal to h over DE into DE over 60. These two DE gets cancelled. When we multiply these two terms we get 3. So the value of h we get it is 60 over 3 that is equal to 20 meters. This is the value of h that we obtain. It is equal to 20 meters. That is the difference between the height of the two towers, or we are saying difference between the height of the tower and the building, it is 20 meters. Next we have to calculate the value of the distance between them, that is we have to calculate the value of DE. Now if we substitute this value of h in this equation we will get DE is equal to 20 root 3 that is equal to 20 into 1.732 and that comes out to be 34.64 meters. So we are saying that the distance between these two is 34.64 meters. So value of root 3 is not given in the question, so you can leave the answer up to this place also, that the distance between the two towers is 20 root 3 meter, or you can use the value as 1.732 and obtain the answer as 34.64 meters. Next is a man on a cliff observes a boat at an angle of depression of 30 degree. We have already seen what is angle of depression. We are saying if we are standing at this point, here this point, this is the point of observation. We are looking at something below us. This is the line of sight. This is the line of sight. This line we are saying this is the horizontal line. Then what is angle of depression? This angle we are saying this is angle of depression. Now in this question it is given that we are standing at this point B and we are observing the two boats that are coming, that are moving, and the angle of depression is observed to be 30 degree. So angle of depression means, when I am talking about I am standing at this point B, I am again explaining it over here, I am standing at this point B, then angle of depression means first of all I have to draw the horizontal line. Angle of depression means this angle, I am saying this angle is 30 degree and boat is somewhere over here. Then it is approaching the shore and with this uniform speed. After 6 minutes the angle of depression of the boat is found to be 60 degree. Now the new angle of depression we have, it is 60 degree and the boat has reached up to this point. We are saying how much distance it has traveled. We are saying it has traveled for 6 minutes. Now the speed of the boat, it is given to be the uniform speed. So suppose we are saying the distance it has traveled in 6 minutes, it is x meters. Now what we have to do is, we have to find the total time taken by the boat to reach the shore. Suppose this distance we are talking about, this is y meter, and this height we are saying it is h meters. Now look at this angle at B. This angle is 30 degree. These two lines, these are parallel to each other. We are talking about these two lines, these are parallel to each other. So if this angle is 30 degree, then this angle over here it is 30 degree, and this angle over here it is 60 degree. So when we are talking about the triangle ABD, what we have is that tan 60, that is equal to root 3, that is equal to h over y. When we are talking about the triangle ABC, we have tan 30, that is equal to 1 by root 3, that is equal to h over x plus y. Now suppose we are saying that the speed of the boat is z meters per minute. The values that are given to us in minute and minute. So we are considering that the speed is z meter per minute. Then we are saying the time taken by the boat to reach the shore. This point we are saying that how much time will it take to reach the shore. That will be distance over speed, that is the value we will get, that will be y over z minutes. Now from the first equation, what we have is that h is equal to y root 3. From this second equation, we have h is equal to x plus y root 3. Now if we equate both these values, it is x plus y over root 3. So if we equate both these values, we are talking about both these values, these are equal. We are writing y root 3 is equal to x plus y by root 3. So this gives us 3y is equal to x plus y. So we get 2y is equal to x. Now what this thing means is, if this distance is x, then this distance y, this will be x by 2. It means if it is taking 6 minutes to cover this distance x, then how much time will it take to cover this distance x by 2? That will be 6 by 2, that is equal to 3 minutes, because the speed is given to be uniform speed. So we are saying to cover this distance, we are talking about this dA distance, it will cover in 3 minutes. DC distance it is covering in 6 minutes. So the total time taken by the boat will be sum of these two, that is equal to 9 minutes. Now in this next question, it is given that we have a lighthouse. So this AB is the lighthouse, and the height of this lighthouse is given to be 75 meters. This is the point of observation. This point B is the point of observation. This line we are saying this is the horizontal line for this point of observation. The angle of depression, they are 30 degree and 45 degree for the two ships at the point C and D. So we are saying if this angle is 30 degree, then this angle is also 30 degree, because these two lines, this horizontal line and this line, these are parallel to each other. So these two angles, these are equal to each other. Similarly, these two angles, these are equal to each other. Now we have to find the distance between the two ships. So we suppose that the distance between the two ships, it is x meters, and the distance of the point A to D, this distance we are supposing it is y meters. So if we consider the triangle BDA, we have tan 45 that is equal to 1, that is equal to 75 over y. So this gives us y is equal to 75 meters. The value of this y we obtain, it is 75 meters. Next, if we consider this whole triangle ABC, we have tan 30 that is equal to 1 by root 3, that is equal to 75 over x plus y. This whole distance we are saying this is x plus y. The value of y we have, it is 75. So we get x plus 75, that is equal to 75 root 3. So the value of x we get, it is 75 into root 3 minus 1. So it is x is equal to 75 into the value of root 3, it is given to be 1.73. So the answer we get, it is 0.73, and the value comes out to be 54.75 meters. Next is two ships are approaching a lighthouse from opposite directions. So we are saying this A, B is the lighthouse, and two ships, they are, one is at the point C and other is at the point D, and it is given that they are in the opposite directions of the lighthouse. One is in this direction, other is in this direction. The angle of depression of the two ships from the top of the lighthouse, this is the point of observation. Then this is line of, this is the horizontal line, because this is the point of observation, so this is the horizontal line. The angle of depressions are given to be 30 degree and 45 degree. What we have is these two lines, these are parallel to each other. So if this angle is 30 degree, then this angle at C is 30 degree. If this angle is 45, then this angle is also 45 degrees. Now if the distance between the two ships is 100 meter, this whole distance is given to be 100 meter. We have to find the height of the lighthouse. So suppose we are saying the height of the lighthouse, it is h meter, and this distance we assume it is x meters. This is the distance between A and C. So this remaining distance over here, this will be 100 minus x meters. So again we are considering first the triangle ABD. We have tan 45 that is equal to h over 100 minus x. This is equal to 1. We get h is equal to 100 minus x. Second, we are considering the triangle BAC. We have tan 30 that is equal to h over x, that is equal to 1 by root 3. So the value of x we get, it is root 3 times h. We have to find the height of the lighthouse. So we substitute the value of x in this equation, and we will obtain h is equal to 100 minus root 3h. So 100 is equal to root 3 plus 1 times h. So the value of h we get, it is 100 over square root 3 plus 1. We multiply and divide it with root 3 minus 1. This denominator part will become 3 minus 1, that is equal to 2. This 2 gets cancelled over here, it is 50 over here. The answer we are getting, it is 50 into 1.732 minus 1. On solving this, you will get it is 36.6 meters. So this is the value of h that we have to calculate. That is the height of this lighthouse, it is 36.6 meters. Now the next we have is from the top of a lighthouse, the angle of depression of two ships on the opposite sides of it are observed to be alpha and beta. So we are saying this lighthouse AB is given. The point of observation, this is B. The horizontal line, if we draw over here, it is this line. Now the angle of depressions are given to be, this angle is given to be alpha and this angle is given to be beta. If this angle is alpha, we are saying these two lines these are parallel, so this angle is also alpha and this angle is beta. Now we have assumed that this length CA it is x and this AD it is y. So we have to find if the height of the lighthouse it is given to be h and the line joining the ships pass through the foot of the lighthouse. Show that the distance between the ships is, you have to prove that the distance between the ships is this much. It means we have to prove that the value of x plus y is equal to this. So we are writing the equations for the two triangles. First is we are writing for this triangle ABC. We have tan alpha is equal to h over x. For the second triangle we are writing BAD. We have tan beta is equal to h over y. So from the first equation we get the value of x is equal to h over tan alpha. From this second equation we get y is equal to h over tan beta. We want to calculate the total distance between these two. So that is x plus y. H is common. It is 1 over tan alpha plus 1 over tan beta. On taking the LCM we will get it is tan alpha plus tan beta over tan alpha tan beta, and this is the total distance between the two ships. Now the next question we have, the angle of elevation of a cloud from a point h meter above a lake is alpha. So we are saying this is a lake we have, then a point A is there on the lake and this is the point of observation we are talking about. Point P is the point of observation. We are standing h meters above this lake. So the line, horizontal line corresponding to this is the horizontal line we are seeing. Now it is given that the angle of elevation of a cloud, it is alpha. This is the cloud we are talking about. And the angle of depression of the reflection in the lake is beta. This is the cloud and this is the reflection of this cloud in the lake. And the angle of depression of this reflection it is beta. We have to prove that the height of the cloud is h tan beta, these values we are talking about, plus tan alpha over tan beta minus tan alpha. Now we are assuming that the height of this cloud it is x meter. This value is given to be h meter. This value it is already given to us in the question. This is h meter. Now by the property of the reflection we are saying that if this distance is x plus h meter, then this distance, the point or the depth at which the reflection will be formed, that will also be x plus h meter. This thing we are getting from the property of the reflection. So if we are considering the triangle this PQC, we are saying tan alpha that is equal to x over PQ. Next we are considering this triangle PQD. We get is tan beta. For this is the perpendicular we are talking about. For this triangle, this total height will be x plus h, that is equal to x plus 2h. This is the perpendicular for this, x plus 2h, and this is the base for this angle we are saying it is beta. For this is the perpendicular and this is the base. So we are saying the base we have it is PQ. Now if we divide both these equations, we will get tan alpha over tan beta, that is equal to x over PQ into PQ over x plus 2h. This PQ gets cancelled. So we can write it is tan beta over tan alpha, that is equal to x plus 2h over x. So write it is x over x plus 2h over x. These gets cancelled. So what we get is 2h over x, that is equal to tan beta over tan alpha minus 1. So it is tan beta minus tan alpha over tan alpha. You are saying these values we get in this form. Now what we want to calculate is, we want to calculate the value of h. So the value of x that we get from this, that is equal to 2h tan alpha over tan beta minus tan alpha. So this is the value of x that we are obtaining. Now we move on to our next slide. We are saying this is the value of x that we have. Now the height of this cloud, it is x plus h. This is the height of this cloud. Height of the cloud. So the answer we get, it is h plus 2h tan alpha over tan beta minus tan alpha. We take h common and we take LCM. It is tan beta minus tan alpha plus 2 tan alpha over tan beta minus tan alpha, and this is equal to h into tan alpha plus tan beta over tan beta minus tan alpha, and this is what we have to prove. Now next we have is the angle of elevation of a cloud from a point 60 meter above the surface of the water. This is similar kind of question. So in previous question the angles were given to be alpha and beta and height was h. Now this is the particular values are given to us. So we are saying the point of observation over here, this is the point P, this is point of observation, and this is at a height of 60 meter from the lake. This is the cloud we are talking about. The angle of elevation of cloud is 30 degree. The angle of depression of its image, this is the reflection we are talking about. Reflection of this cloud, it is at this point D, and the angle of depression, it is 60 degree. We have to find the height of the cloud from the surface of water. So again we are talking about this height QC, we are saying it is x meter. This QB we are saying it is 60 meter. Now if we consider this triangle PQC, we have tan 30, that is equal to 1 by root 3, that is equal to x over PQ. When we are considering this triangle over here, this triangle we are talking about, we are saying tan 60, that is equal to, this total height is x plus 120. This is x plus 60, this is 60. By adding these two we get it is x plus 120, that over PQ. Why this is x plus 60? The reason we have given was that it is by the property of the reflection that whatever the height we have over here, that is BC height, and this height we are talking about BD height, these should be equal. This is by the property of the reflection we are talking about. Now we have two equations and we want to calculate the value of x. So we divide these two equations. We are dividing the second equation with first equation. So we get root 3 into root 3, that is equal to x plus 120 over PQ into PQ over x. These two gets cancelled and we are left with this x plus 120 over x. This is equal to x over x plus 120 over x. These two gets cancelled, we are left with 1, and root 3 into root 3, this value is 3. So we get 2 is equal to 120 over x. So the value of x that we get, it is equal to 60. The value of this x, we are saying this is 60 meter. We want to find the height of the cloud from the surface of the water. So we are saying the total height of this cloud from the surface of the water, that is 60 plus 60, that is equal to 120 meters. Now next we have is a round balloon of radius r subtends an angle alpha at the eye of the observer. So this round balloon we are talking about, this is the round balloon, and this is the point of observation we are talking about. When this balloon is observed, we are saying it is making an angle alpha to the eye of this observer. So this total angle over here, this is alpha. We are saying we are joining these points O and C, and the half of this angle, this is alpha by 2, half of this angle, this is alpha by 2, and the angle of elevation of its center, angle of elevation of its center means this is the center C we are talking about. The angle of elevation of its center, it is beta. We have to prove that the height of the center of the balloon is, we are talking about this height we are talking about. We have to prove that this height is r sine beta into cosecant alpha by 2. So by the properties of the circle, we know that this OA is the tangent, so this angle is 90 degree. OB is the tangent, so this angle is 90 degrees. This angle at D is 90 degrees. So from the triangle OAC, we are talking about this triangle. This is the triangle OAC we are talking about. I'm again drawing this triangle over here. What kind of triangle is this? This angle at A, it is 90 degree. Then this angle at O, it is alpha by 2, and this is the point C we are talking about. AC length we have, it is R. Then we have sine of alpha by 2, that is equal to R over OC. It is perpendicular over hypotenuse. And if we are talking about the triangle ODC, we are talking about this triangle over here. In this triangle, we are saying the value of sine of beta, that is equal to perpendicular. Perpendicular is CD over hypotenuse. We are saying it is OC. Now we want to eliminate this OC from both the equations. To eliminate OC, we are saying we are dividing both these equations. We are dividing these equations and we get it is sine alpha by 2 over sine beta, that is equal to R over OC into OC over CD. This OC gets cancelled. We want to calculate the value of CD. So that is equal to R sine beta into 1 over sine alpha by 2. So we get CD is equal to R sine beta into cosecant alpha by 2. So this is what we have to prove. Next we have is a boy whose eye level is 1.5 meter from the ground spots a balloon moving with the wind in a horizontal line at some height from the ground. So suppose we are saying this AB is the boy and the level of his eye is at this point B. This means this point B is the observation point. The height of this boy, it is given to be 1.3 meters, and he spots the balloon at these points. The angle of elevation of the balloon from the eye of the boy at any instant is 60 degree. We are saying at some time t, the angle of elevation of the balloon, it is 60 degree, and after 2 seconds the angle of elevation reduces to 30 degree. Now if this angle is reducing to 30 degree, it means the balloon is moving away from the buoy, because if it is moving towards the buoy, the angle of elevation will increase. So we are saying after 2 seconds the balloon will reach at this point D. If the speed of the wind is, it is moving with the, because of the wind, so the speed of the wind, it is given to be 29 root 3 meter per second. Then find the height of the balloon from the ground. So we have first drawn the perpendicular. We have drawn from this point C, we have drawn the perpendicular over here. We have from D, we have drawn this perpendicular, and from this B we have drawn this line of this horizontal line. These are the angles we have. This is the angle 30 degree and this is the angle 60 degree. We are talking about at D, this is the angle this, and this angle over here, this is 60 degrees angle. Now we have two triangles. One is this triangle BPC. In this triangle we are saying tan of 60 degree. The angle over here, it is 60 degree. So tan of 60 degree, that is equal to root 3, that is equal to PC over X. When we are talking about this larger triangle over here, BDN, this triangle we are talking about, then we have tan of 30 degree, that is equal to 1 by root 3, that is equal to DN over BN. Now this length DN and this length PC, these two lengths, these are equal to each other. We are saying this PC and DN, both these lengths, these are equal to each other. We are saying this is equal to PC, and the value of DN that we have, it is this value we are talking about, BN length. This is X meter length and this is 58 root 3 meter length. So what we get is that this is equal to PC over 58 root 3 plus X. Now if we divide both these equations, we get root 3 into root 3, that is equal to PC over X into 58 root 3 plus X over PC. These two values gets cancelled, and what we are left is 58 root 3 over X plus 1. This term will become 3. So we will get 2 is equal to 58 root 3 by X. So this gives us X is equal to 58 root 3 by 2. That is equal to 29 root 3 meters. So we are saying the value of X that we have, it is this length we are talking about. This is 29 root 3 meters. Now we want to find the height of the balloon. So we substitute this value of X in our first equation. It is root 3 is equal to PC over X. So the value of X we get, that is equal to 29 root 3 into square root 3. So the answer we get, it is 29 into 3, that is equal to 87 meters. So we are saying this length PC or this height DN, these are equal to 87 meters. Next we have is an aeroplane when flying at a height of 3000 meters from the ground passes vertically above another aeroplane at an instant when the angle of elevation of the two planes from the same point on the ground are 60 degree and 45 degree. So we are saying two aeroplanes are there. One is this aeroplane A and one is this aeroplane B, and at some instant of time they are above. One aeroplane is above the second aeroplane, and this total height, this height A of this aeroplane, it is given to be 3000 meters. Suppose the distance between these two, the height of the difference between their heights, it is x meters. We are talking about this difference, it is x meters. It is given that the angle of elevation of one aeroplane, it is 45 degree, and second aeroplane, it is 60 degree. It means the aeroplane which is higher, it will have an angle of elevation of 60 degree. The aeroplane which is lower, it has angle of elevation of 45 degree. So we have to find the vertical distance between the aeroplanes at any instant. It means we have to calculate the value of this x. We have to calculate this distance A, B. So if we are considering this triangle OCB, we are saying tan 45, that is equal to 3000 minus x over OC, and this is equal to 1. So we get 3000 minus x is equal to OC. Now if we consider this triangle OAC, we are writing it is tan 60 is equal to AC over OC. It means root 3 is equal to this AC length. This AC length we are talking about, it is given to be 3000 over OC. So what we get is that the value of OC we have, it is 3000 by root 3. Multiply and divide it with square root 3, and we get it is 1000 root 3. We substitute this value over here, and we get that the value of x we have, it is 3000 minus 1000 root 3, and this value comes out to be 3000 minus 1732, and the answer we obtain on subtracting these two, it is 1270 meters, and this is the vertical distance between the two aeroplanes at any instant. Now next we have is a man standing on the deck of a ship which is 10 meter above the water level observes the angle of elevation of the top of a hill is 60 degree. So we are saying this is the water level, then this is the height of the deck of the ship. The man is standing at this point, so this is the point of observation, this point B. This line we have drawn over here, this is the horizontal line corresponding to this line of observation, and it is given that it is observing the top of the hill, and the angle of elevation we have, it is 60 degree. This point D, this is the top of hill, and then it is also observing the base of that hill. We are saying this point C, this is the base of hill, and the angle of depression that we have, it is 30 degrees. So we have to find the distance of the hill from the ship and the height of the ship. So if we are talking about this triangle, I'm talking about this triangle BED, we have tan 60 degree, that is equal to, suppose the height of this hill we are saying it is h, this distance is given to be 10 meters, so this remaining distance is h minus 10 over, it is BE is the distance between the ship and the hill, and this value is equal to square root 3. If we are considering this triangle BEC, we are talking about this triangle BEC, we have tan 30 is equal to, now the perpendicular is this 10, we are talking about this angle, so this is the perpendicular and this is the base. The base value we are saying it is BE, and we are saying this value is equal to 1 by root 3. If we divide both these equations, we are getting h minus 10 over BE into BE over 10, that is equal to root 3 into root 3. BE gets cancelled, we get h minus 10 is equal to 30. So the value of h we get, that is equal to 40. From this equation we are getting BE is equal to 10 root 3 meters. So these are the two values that we have to calculate. We are saying BE means this distance between the ship and the hill, and this height h is the height of the hill. Now the next we have is, from a window h meter high above the ground of a house in a street, the angle of elevation and depression of the top of and foot of another house on the opposite side of the street are theta and phi respectively. So we are saying a house is there, this is the AB is the house, and at this point B there is a window, and we are looking at another house on the opposite side of street from this point. So this is the observation point. This point, it is the observation point. This line we are saying this is the horizontal line corresponding to this observation point. We are looking at another building. This is the second building we are talking about, DC. This is another building. We are looking at the top of this building, and the angle of elevation, it is theta. We are looking at the foot of this building, the angle of depression, it is phi. We are talking about these angles over here. We have to show that the height of the opposite house is this, h into 1 plus tan theta into cot phi. So we are saying this height, this total height of this building, it is capital H. Now the height of this building over here, it is small h. The height of this building is capital H. So this height we are saying it is small h, and this remaining height will be capital H minus small h. So if we look at this triangle BDE over here, in this triangle we are saying tan theta, that is equal to capital H minus small h over BE. When we are talking about this triangle BCE, we are talking about in this triangle tan phi we are talking about. When we are talking about this angle phi, this side is the perpendicular and this side is the base. So what we get is that this value is equal to h over BE. Now we want to calculate the value of capital H. So we are dividing both these equations, and we get tan theta over tan phi, that is equal to capital H minus small h over h. This is capital H over small h minus 1. So we get h over h, that is equal to tan theta plus tan phi over, or in place of this we are not taking the LCM over here, we are just leaving it like this, over tan phi plus 1. So the value of capital H we get, it is small h tan theta cot phi plus 1. You can write this is 1 over tan phi, and the value of 1 over tan phi, it is cot phi. So we are saying that the height of this whole building, that is equal to small h into tan phi cot phi plus 1. Now next we have is, from the top of a building 60 meter high, the angle of depression of the top and bottom of a tower are observed to be 30 degree and 60 degree. Now first thing, we are talking about the angle of depressions. If we are standing on the top of a building, we are talking about this AB is the building, this point B is the observation point, this is the horizontal line. We are talking about angle of depression of another building. It means the other building we are talking about, it is of lesser height than this original, this first building we are talking about. So the angle of depression to the top of this building, it is 30 degree, and angle of depression, this value is given to be 30 degree, and the angle of depression, the base of this building, it is 60 degree. So we get that this angle at D is 30 degree and this angle at C, it is 60 degrees. We have to find the height of the tower. So suppose we are saying the height of this smaller tower, it is small h, and height of this larger tower it is capital H. So this height BE, this will be capital H minus small h. So if we consider the triangle DBE, in this triangle we are saying tan 30, that is 1 by root 3, that will be equal to capital H minus small h over x. X is the distance between the two buildings we have considered. Next we have, if we consider the triangle BCA, we are talking about this triangle, we have tan of 60 degree, that is equal to root 3, that is equal to capital H by x. If we divide both these equations, we get 1 by root 3 into 1 by root 3, that is equal to capital H minus h over x into x over capital H. These x gets cancelled, and what we are left with is h over h minus small h over capital H. This is equal to 1 minus small h over capital H. So we are saying small h over capital H is equal to 1 minus 1 by 3, that is equal to 2 by 3. Now the value of this capital H is given to be 60 meter. We are talking about, we are observing from the height 60 meter. So we get H is equal to 2 by 3 into 60, and the answer we obtain, that is equal to 40 meters. So height of this smaller building will be 40 meters. Now next is the angle of elevation of a jet plane from a point A on the ground is 60 degree. So we are saying some point A is there on the ground. So this is the point A we are talking about, and the angle of elevation of this jet is 60 degree. So jet is at this point P, and the angle of elevation it is given to be 60 degree. After a flight of 30 seconds, the angle of elevation changes to 30 degree. So we are saying the angle of elevation is decreasing. It means it is moving away from the observer. This is the observation point. It means it is moving away from the observer, and the new angle of elevation it is 30 degrees. If the jet plane is flying at a constant height of, this height is given to be 3600 root 3 meters, we have to find the speed of the jet plane. So we are considering first the triangle ABP. In this triangle we have tan 60 is equal to 3600 root 3 over AB. This height we are saying, these two heights, these are equal. When we are considering the triangle ACQ, next we are considering the triangle ACQ, and we obtain tan 30, that is equal to root 3, that is equal to, in this triangle when we are talking about, we have the value, it is QC. Again the value of QC, it is 3600 root 3 upon AC. Now from this first equation we are talking about, this value is equal to root 3. So the value of AB we obtain, that is equal to 3600 meters. This is the value of AB that we obtain. It is 3600 meters. From the second equation, we are saying AC is equal to 36. This is 1 by root 3. So this is 3600 into 3 meters. This AC is equal to AB plus BC. So this is equal to, we are saying the value of AB it is 3600 plus BC equal to this value. So we get that the value of BC is 7200 meters. The value of BC we have, this distance we are talking about, it is 7200 meters. Now it is given that the aeroplane has taken 30 seconds to travel this distance. We are saying in 30 seconds the aeroplane has traveled 7200 meters. So in 1 second it would have traveled 7200 over 30 meters. So it means its speed is 72, these two gets cancelled, and the value we are left with is 240 meters per second. If we convert it to kilometer per hour, the answer you will get, it is 864 kilometers per hour. Next is the angle of elevation of a jet fighter from a point A on the ground is 60 degree. After a flight of 15 seconds, the angle of elevation changes to 30 degree. So we are saying this O is the point of observation. The point A with the angle of elevation 60 degrees over here. Then after 15 seconds, we are saying it has moved 15 seconds. The jet has reached the point B. The speed with which it is traveling, it is 720 kilometer per hour. It means this distance is 720 kilometer per hour. How much time it has traveled? It is 15 seconds. So 15 second means we are talking about it is upon 60 into 60 and into 1000. So what we get is that the total distance traveled, it will be this, and this comes out to be 3000 meters. We are saying this is the speed in kilometer per hour. This is the time in seconds. So to convert this, we have multiplied, divided it with 60 into 60, and we have converted the distance to meters by multiplying it with 1000. So the total distance traveled we have, it is 3000 meters. So we are saying this distance we have, LM distance, we are saying it is 3000 meters. Now we have to find the constant height at which the jet is flying. So suppose we are saying the constant height that we have, it is h, and this distance OL we are saying it is x meters. So in the triangle OAL we have tan 60, that is equal to h by x. So this gives us h by x is equal to root 3. In the triangle BOM we have tan 30, that is equal to h over x plus 3000, and this is equal to 1 by root 3. The value of h we get from this, it is root 3 times x. So we get root 3 times x over x plus 3000, that is equal to 1 by root 3. So we get 3x is equal to x plus 3000. This gives us x is equal to 1500. This gives us x is equal to 1500 meters. So we are saying this length is 1500 meters. Now if we substitute this value of x in this equation, we obtain that h is equal to 1500 root 3, and that comes out to be 1500 into 1.732, and the answer we get, it is 2598 meters. So this is the required value that we have to calculate, that is the constant height at which the aeroplane is flying. In this question it is given that a 1.2 meter tall girl, so girl we are saying this is A, B, it is, she is over here, and this point B is the observation point. The height of the girl is given to be 1.2 meters, and she observes a balloon moving with the wind at a horizontal line at a height of, the balloon, it is at a height of 88.2 meters. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. We are saying the angle of elevation is 60 degree over here. This is when it is at the point C. After some time, the angle of elevation reduces by 30 degree. It means it is moving away from the gulf, and the angle of elevation it reduces to 30 degree when it reaches the point D. Find the distance traveled by the balloon during the interval. You have to find this length CD. So to calculate this length, we have drawn the perpendicular from C, we have drawn the perpendicular from D, and this BN line, we are saying this is the horizontal line. Now in the triangle, this triangle we are talking about CBP, we have tan 60 degree, that is equal to CP over BP. And in the triangle BND, we are talking about this triangle over here, we have tan 30 degree, that is equal to DN over BN. Now this length NM is given to be 1.2 meters. It means this length DN we have, it is 88.2 minus 1.2, that is equal to 87 meters. We are talking about this length DN, this is 87 meters. We are talking about the length PC, it is 87 meters. The value of tan 60, it is root 3. The value of tan 30, it is 1 by root 3. So from the first equation, from this equation, we get the value of BP, that is equal to 87 by root 3. We multiply and divide it with root 3, we get 87 by 3 root 3, and the value comes out to be 29 root 3 meters. Now from this second equation, we have the value of Bn, that is equal to 87 root 3 meters. So we have the value of Bn, means we are talking about this whole length over here. This length we are saying it is Bn, and BP is the value of this much portion, we are saying this is BP. What we require is, we require the length Pn, that is equal to Lm. We are talking about this distances we want to calculate. So the value we get, it is 87 root 3 minus 29 root 3, and the answer we get, it is 58 root 3 meters. So this is the distance traveled by the balloon during this interval. Now the next we have is, a tree breaks due to storm and broken part bends so that the top of the tree touches the ground, making an angle of 30 degree. So we are saying this was the whole tree we are talking about. It has broken from this point C, and this point B, it reaches over here. It means we are saying if this length is Y, then this length over here it is Y. This BC part, it is broken and it reaches over here, and the angle it is making with the ground, it is 30 degree. The distance between the foot of the tree at the point where the top touches the ground is 9 meter. The distance, this AD distance, it is 9 meter. We have to find the height of the tree. So we have this angle is 30 degree. So this value we have, it is x. So we are talking about tan 30, that is equal to x by 9. So the value of x that we get, it is 9 by root 3. We multiply and divide it with root 3, and the answer we obtain, it is 3 root 3. This is the value of x that we get. This value we are saying it is 3 root 3. Next we want to calculate the value of y. So either we can use the Pythagoras theorem to find this, or we can use the angle we are talking about, sine 30, that will be equal to perpendicular over hypotenuse. The value of sine 30 we have, it is 1 by 2. So the value of y we get, it is 6 root 3. So the total height of the tree, this total height we are saying that will be x plus y, that is equal to 9 root 3 meters. This is the total height of the tree. Next is, a person standing on the bank of a river observes that the angle of elevation of the top of a tree standing on the opposite bank is 60 degree. So we are saying, suppose this AC is the river and the breadth of this river we are saying it is x meters. The tree we are talking about, this is the tree A, B we are talking about. He has observed from this point C, he has observed this tree and he obtains that the angle is 60 degree. When he moves 30 meters away, now he has moved 30 meters away and reached at this point D, he finds that the angle of elevation is 30 degree. He is observing the same point B and he obtains that this angle is 30 degree. Find the height of the tree and the width of the river. So we are saying the width of the river we have assumed it is x and height of the tree we are assuming it is h. So when we are talking about this triangle ABC, we are saying tan 60 degree, that is equal to h by x, that is equal to square root 3. Then we are considering this larger triangle over here. From this triangle we have tan 30 degree, that is equal to h over x plus 30 and this is equal to 1 by root 3. From this equation we get h is equal to root 3x. From this equation we get h is equal to x plus 30 by root 3. Equating both these values, we get root 3x is equal to x plus 30 by square root 3. So this gives us 3x is equal to x plus 30. So the value of x we obtain, that is equal to 15 meter. This is the breadth of this river and the value of h we will obtain, it is 15 root 3, that is equal to 15 into 1.732. That comes out to be 25.98 meter and this is the height of this tree. Now next we have is the angle of elevation of the top of a tower from 2 points on the ground at a distance a meters and b meter from the base. From the tower and the same straight line are complementary to each other. Complementary means sum of both these angles, it is 90 degrees. So if one angle is theta, we are saying the other angle, say it is say A, and we are saying the sum is 90. So the other angle we are saying the value of A will get it is 90 minus theta. So first thing is that both the angles, they will be in this form, that one angle is theta and second angle will be 90 minus theta. The distances are given to be A and B meters. So we are saying, suppose this AB is the tower, this AB we are saying this is the tower and height of this tower it is h meters. We have 2 points D and C. D is the point B meters away from A and C is the point A meters away from A. So what is this length? CD, it is A minus B. We have to prove that the height of the tower is square root of AB. Now the angles that are given to us, they are 30 and theta and 90 minus theta degree. So if we consider this triangle ABD, we have tan of 90 minus theta, that is equal to h over b. When we are considering this larger triangle, we have tan theta is equal to h over a. Now we know from our previous results that tan 90 minus theta, that is equal to cot theta. So if we multiply both these equations, we get cot theta into tan theta, that is equal to h over b into h over a. Cot theta into tan theta, we know this is equal to 1. So we get h square is equal to AB. So the value of h we get that is equal to AB because height cannot be negative. So we are saying that the value of h that we have, it is square root of AB meters. And this is what we have to prove. Now the next question we have is, a boy standing on a horizontal plane finds a bird flying at a distance of 100 meter from him at an elevation of 30 degree. We are saying this is the position of boy, this is the position of bird. The distance between the boy and the bird, it is 100 meters. The angle of elevation is given to be 30 degree. Next, a girl is there who is on the opposite side of the bird. We are saying the boy and the girl, they are on the opposite side of the bird. And second thing that is given to us is that the girl is standing on the roof that is 20 meter high. So we are saying, suppose this is the building we are talking about where the girl is standing. So this is the position of the girl. It is on the opposite side of this bird from the boy. And the angle of elevation over here, it is 45 degree. And this height at which the girl is standing, it is given to be 20 meters. Now we have to find this length OG. So if we are looking at this triangle BLO we are talking about, in this triangle we are saying value of sine 30 that is equal to OL over BO, and value of sine 30 we have, it is 1 by 2. So the value of OL that we have, it is 100 by 2 that is equal to 50 meters. We are saying this whole length, this is 50 meter. So this remaining length will be 30 meters. We are talking about this OM length, this is 30 meters. Now if we consider this triangle OMG, in this triangle we are saying sine of 45 degree that is equal to perpendicular over hypotenuse. Sine of 45 is 1 by root 2. So we get that the value of OG is 30 root 2, and it is 30 into 1.414, or we are using, it is 30 into 1.41, and the answer we get, it is 42.3 meters. So we are saying this is the distance of the bird and the girl. Next we have is, a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So we are saying, suppose this building we are talking about, this is AB is the building, and it is given that the height of this building is 30 meters. Suppose the position of the boy, it is at this point. We are saying it is at the point, this is the position of the boy, and the angle of elevation is given to be 30 degree. Then it is given that the boy moves towards the building and reaches at a point F. This is the new position, and the angle of elevation of the boy, it changes from 30 to 60 degree. The height will remain same, 1.5 meters. We have to find the distance he has traveled towards the building. So the height of this building is given to be 30 meters. This is 1.5 meters. So this remaining height over here, that will be 28.5 meters. Now if we consider the triangle BFG, we are talking about this triangle, we are having tan 60 that is equal to root 3 that is equal to 28.5 over FG. If we are considering the triangle DGB, we are talking about this triangle DGB, we have tan 30 that is equal to 1 by root 3 that is equal to 28.5 over DG. Now from the first equation, we get that the value of FG that is equal to 28.5 by root 3. We rationalize this term, and the answer we obtain that is equal to, it is 9.5 root 3. This is the value of fg we obtained from the first equation. From the second equation, the value of dg that we obtain, it is 28.5 root 3. This is from the second equation. So we are saying we have this length dg, we have this length fg, we have this length fg. So how much distance he has traveled? So distance traveled, that will be equal to 28.5 root 3 minus 9.5 root 3, and the answer we obtained for this, it is 19 root 3 meters, and this is the distance that we have to calculate.